Hi, so today we are going to see a solver-based problem and its solution. So it's called machine selection problem. Okay, so the problem statement is something like this. We have three type of machine 1, 2, and 3, and there is speed like number of bolts per minute they can produce. So machine 1 can produce 5 bolts per minute, machine 2 can produce 9, and machine 3 can produce 25. And operating cost per 100 volt produced, so that is $25 for machine 1, $14 for machine 2, and $4 for machine 3. And ability to make bolts, 1-inch bolt, 2-inch bolt, and 3-inch bolt. So there are three type of bolts that's produced in this different machine. And we have requested number, so total number of bolts required. So client wants 16,000 volt of 1 inch, 3,000 of 2 inch, and 400 of 3 inch. And we have a time limit, like maximum time allowed for water 500. So that means any machine cannot run more than 500 minutes. So we need to fulfill this condition, and we need to fulfill this condition too, that the machine runtime should not be greater than 500. And another condition is that we need to reduce this operating cost or total cost. So this is the problem statement, and here we are going to understand how we need to solve this. So the first, our objective function is that we need to minimize the operating cost or total cost, and constraint is that the total running time for each machine should be less than 500 or equal 500, and total number of bolt produced need to be exactly match this amount. So we have given this amount of data. Now we can say there's 1-inch cardboard. So let's suppose you can say this the two ability to make 1-inch bolt is 1. So let's suppose we are going to cut or use this pattern this amount of time. So let me give 1 for every number. Okay, so we are going to use one type of this, one type of this, one type of this. So number of bolts per machine. So in this machine 1, we are producing machine like this, right? So this is actually, this is some, but if this number is changed, then we need to use some product. So that will be multiply this by this. Okay, and okay, and we are initializing by this number, so we need to get this number exactly. Okay, so how many number of card we need to use for this 1-inch for this machine 1 and for machine 2 and machine 3 when fulfilling this condition that we need this amount of bolt required. So you can see this from the color scheme that these are actually constraint. This is objective function, and this is actually variable cells or decision variable. So we need to change this number, and we need to fulfill this condition. So we just assume that we'll use one quantity of every type of cards. So number of bolt per machine, so in this case that will be 3, because we are using this 3. Okay, so total cost per machines in this case, now I can say this that we have produced number of bolt per machine is 3, right? So we are producing 3 bolt, and we can see this per 100 bolt it's takes $25, right? So we are dividing by 100, and we are also multiplying by that number, right? $25. So That's the total cost per machine. This one, and this one, same in all of this. So total minutes per machine. So actually you can see this, that our speed is that we can produce 5 machine per minute, right? So in this case we are producing 3 unit of bolt, so we need to find that um, total minutes, right? So one, so K4, so that means total number of bolt per machine divided by speed. So this is this gives me the total minute to produce this amount of bolt. This one 0 0. Actually if we use number formatting, then this will be actually 0.6. Okay, so these are all the constraints, that this runtime need to be less than 500 and this total cost need to be less than this need to be minimized, right? This is total cost, this is summation of this cost. So let me delete all of those previous. Okay, so our objective function is this one. We need to minimize this and we are going to change this number. So this is our variable cell and the constraint is that, so this number of course need to be less than or equals to this 500, because this is the maximum time we can run any machines, right? And so at this next condition is that this number need to be equals this number. Actually you can use greater than or equal, but equal is enough. So this is the second condition. Third condition is that this need to be integer, and we can add another condition that this need to be greater than or equals 0. So all of these conditions, I guess we will use this simplex linear programming solution, and if we run this now you can see this, that it's find the solution and it's give me the correct number, or the total cost, minimized cost will be $1,730, and we need to cut in this pattern. Okay, so we need to use machine 1 for, we need to run this machine for 480 hours, sorry, 480 minutes. Second machine will be run 500 minutes, third machine will be run 500 minutes, and this that pattern will be like 2-inch bolt will be 200, produce 200, 3-inch bolt will be produce 400 from this machine 1, and from machine 2 1-inch bolt will be produce 3500 and 2-inch bolt, and this is the SN3. Okay, so in total it will match this number, this one and this one and this one. Okay, so that's it. And if we wants to get the report, then let's run this again and then outline report. We can have the answer and it will produce this answer report 1. So it will give all of those data. So objective cell is L16, total cost minimized, and that is this amount. Variable cell is this one, and all of these are constraint. Okay, you can enlarge this if you want to see the whole things. Okay, that's it. Thank you for watching.